Today I'm going to talk about word problems, sometimes called story problems. They usually seem a little daunting, but I'll try and break them down so that they seem a little more manageable to you. We're going to look at problems in this section that have one or two unknowns, but are certainly linear in nature. What on earth does that mean? Well, it means the unknowns are to the first power, which is a good thing. So here's a problem. I'll just work through two. This is the first one. A number increased by 12 is 4 times the number. Find the number. In word problems, I usually read through the entire word problem, and then at the very end, it will tell me what my unknown is. It'll either hand it to me in the form of a question, or like in this case, it says find the number. So if I'm looking for the number, then that must be my unknown. That has to be what I'm looking for. Find what number, right? What's the number? So I'm gonna, since it's a number, I try to pick a letter that looks something like what I'm trying to find. So I'm gonna let n be equal to a number. So often I'll write down exactly what it is, and then often I don't even put a equal sign. I erase that because I tend to, it's just my habit, probably a teacher showed me at one time, I put sort of a long Z, maybe even with an arrow saying n is going to be this thing that I call a number. So now I'm just going to write down what it tells me about this. Well, it says a number. If I go back to the beginning, a number, well, I know what a number is. It's n, so I'm going to write that down. N is increased by 12. So if I have n of them, I'm going to add 12. Right? So I take a number and I increase it by 12. And then it says it is. Is most often in mathematics is an equal sign. So it's 12, n plus 12 is, or equals, 4 times, times being multiplication, right? 4 times the number n. So I'm just going to write 4n. We know there's a multiplication right there. So now I'm going to solve this just like I would any other linear equation. Right? Do you remember how to do these? I'm going to move all the variables to the left. Using addition, I'll add 4n to this side. I'll add 4n to this side. That leaves me with, oops, I made a big mistake, didn't I? I don't want to add 4n. I have 4n. I'm going to subtract 4n. Good catch. Alright, so subtract 4n, subtract 4n, because I looked over on the right and I went, wait, if I add 4n and 4n, I'll get 8n, and I don't want any of them. So here I'm left with minus 3n plus 12 equals what? Well, if I have 4n and I subtract 4n, I'm left with nothing. So this goes to 0. Now I'll subtract 12 from both sides to get all the numbers onto the right-hand side, and I'm left with minus 3n is equal to minus 12n. Easily done. I'll just divide both sides by minus 3. Or I could multiply both sides by negative 1/3. Same thing, right? We know that. Alright, so the minus 3 over 3 is just 1. And that leaves me, I'll continue it over here on the, let me draw a line down the page. That leaves me now, if I come up over here, it leaves me with n is equal to minus 12 divided by minus 3, which equals a minus divided by a minus is positive. 3 goes into 12 4 times, so n is equal to 4. So my number, find the number, n, which was my number, happens to be 4. So 4 is the number that works. Let's check this. Let's check. Well, if I take 4 and I add 12 to it, is that the same thing, question, as 4 times 4? Well, 4 plus 12 is 16, and certainly that equals 4 times 4, which is 16. So we have found the number. Alright, so just as a summary, I read the entire question. I look at the very last line, perhaps the last line, or look at the very last question, and it will hand me my variable. It will hand me the unknown. Then I go back through the problem using that unknown and try and write some sort of equation. Great. So let's look at a problem that's a little more complicated that has two unknowns. Okay, in this case this is a bookcase, believe it or not. The height of the bookcase is 3 feet longer than the length of a shelf. So if the length of a shelf is from here to say here, this first sentence tells me the height is 3 feet longer. So it tells me the height of my bookcase is longer than the shelf. So it's higher than it is wide, right? If 18 feet of lumber is available for the entire unit, find the length and height of the bookcase. Well, here's that last sentence. Find the length and height of the bookcase. So it's telling me my two variables. I'm going to let the length be L and the height be H. I like to pick, if possible, the first letter because it's descriptive. It tells me as I'm going through I don't have X and Y. I don't have to remember which one was X, which one was Y. I know that L stands for length, H for height. Then I'm going to actually draw this in on my drawing. Height is H and length is L. So now we go back to the problem and figure out what else we are given, what can we do with this. The height of the bookcase, H, it says is 3 feet longer than the length. So it's L plus 3. That's the first thing they tell us. That's one equation, but I have two unknowns. They also tell me I have 18 feet of lumber available. So 18 is all I've got. And that has to give me everything. So 18 would be, say, this side of the bookcase, right? That's H, but I've got another side over here that's also going to be H high. So I've got two of these lengths H, and then I've got a shelf here. I've got a shelf here, a shelf here, and a top. So I actually have 4 pieces of wood I need for the top and the 3 shelves, so 4L. So now I have 2 equations and 2 unknowns. Let's see how to solve that. Let me rewrite them for you. I'm going to use this formula, the second one, and we'll notice we've got H sitting here. But H, I'm told by the first formula, is the same thing as L plus 3. So instead of H, I can substitute in L plus 3 because H equals L plus 3. So this second formula becomes 18. Let me just draw a line here to show that I'm kind of doing something a little different. I'm going to substitute in L plus 3 for H, so I have 18 is equal to 2 times the whole quantity L plus 3 plus 4L. And you'll notice now L is the only variable. So we can solve it. We can solve it just the way we know how. So let's do that. The first thing I need to do is get everything into terms. So this is 18 is equal to, I'll distribute the 2. 2 times L is 2L. 2 times 3 is plus 6 plus 4L. I'm going to subtract 6 from both sides, and I get, over here I get 12 is equal to 2L plus 4L, because clearly plus 6 and minus 6 add up to 0. And what is 2L plus 4L? Well, these are like terms, so I can add them and call it 6L. 12 is equal to 6L, but 6L is also equal to 12, right? So we can just, that's one nice thing about an equation, is you can just move everything from one side to the other, because they're equal. And then I'll just divide both sides by 6. So L in this case is equal to 2. L is equal to 2. Let's go back and see what the question was. I want to make sure we answer it. Find the length and height of the bookcase. Oh, we found the length. How are we going to find the height? So we found L was equal to, let's put that in, L was equal to 2, but we still need the height. Well, we had this relationship for the height and the length. H was equal to L plus 3. So I'll go back to my, where I was working this equation. L is equal to 2, and I know that H is equal to L plus 3, or H is equal to 2 plus 3, or H is equal to 5. Alright, so H is equal to 5. Now this is a word problem, so let's go back one more time. We were given 18 feet of lumber. Right, so everything is in feet, so I want to make sure I put the units in. So L is equal to 2 feet, H is equal to 5 feet. So our bookcase is 2 feet wide, 5 feet high. And that's it. Good.